There are two types of capacitors we use in HVAC. The run capacitor is used mainly for fan motors and compressors to aid in running efficiency. The run capacitor is in the electrical circuit all the time. The start capacitor is used to aid starting a fan motor or compressor and is in the electrical circuit for a short period of time at startup. What is the function of capacitors? The first thing capacitors do is resist voltage change and store voltage. The second thing they do is frequency filtering, and the third thing is phase shift. All of these are present in HVAC work, but the main thing that we are concerned about is the phase shift. Capacitors are constructed of a roll of metallic film with an insulating material between each roll. This metallic roll stores the electrical charge. Another example of a capacitor is a cloud in a storm. Electrical charges are stored in the cloud, with air being the isolating material. When the charge gets to a certain point, it is released in the form of lightning between the cloud and the ground. A start capacitor has a plastic case, as it is in the electrical circuit for a short time and has the whole cycle to cool down. A run capacitor has a metal case, as it is in the electrical circuit the entire time, and the circulating air around it keeps it cool. This is a standard single-phase 60-cycle electric sine wave as seen on an oscilloscope. Let's see what a capacitor does to this sine wave. Here we see the voltage and the current basically in phase with each other without a capacitor. And here we see the voltage leading the current with a capacitor added, the phase shift that we talked about earlier. This is a standard compressor with a start capacitor and a run capacitor wired into the circuit. The green line on the sine wave shows the applied voltage being applied to the compressor. The purple line shows the starting current when the start capacitor is still in the circuit at startup. And the orange line is the running current when the compressor is running with the run capacitor in line. Notice the phase shift on the starting and the running current. A number of years ago, our parts department received a call from a technician who wanted a start relay and a start capacitor for a three-phase compressor. He clearly did not understand that with a three-phase compressor, the three phases already lead each other as the compressor is starting and running. And so therefore, a start gear is not needed on a three-phase compressor or motor, as the second and third phase leads the compressor or the motor, and so assists in startup and also assists in running efficiency. Manufacturers used to manufacture shaded pole motors, which had a dissimilar type metal in the windings of the motor. This would throw the phase off, much like a capacitor, and would aid in the startup and the running efficiency of the shaded pole motor. You don't see these too much anymore, but if you do see something like this, that's what it's for. Instead of having a capacitor on it, they put dissimilar metal into the windings to throw the phase out. This is a wiring diagram of a permanent split capacitor or PSC motor, which was standard for many years. It had the run capacitor in the motor circuit all the time. This would aid in the running efficiency of the motor. This is a wiring diagram of a capacitor start, capacitor run, or CSR system, which is usually seen on compressors where you have a start capacitor and a start relay, and also a run capacitor. So in this case, you would have a run capacitor that would be in the circuit at all times to aid in the running efficiency of the compressor. And you would also have a start capacitor, which would be controlled by a start relay that would take the start capacitor out of the circuit after a few seconds of starting. On all capacitors, you will have a data tag which will give you the voltage and MFD rating for that capacitor. For run capacitors, you want to replace them with a capacitor that is equal to or greater in voltage, and on the microfarad rating, you can go plus or minus 10%. For start capacitors, you want a voltage that is equal to or greater than the one you're replacing, and the microfarad needs to be equal to or can be up to 20% higher. For start capacitors, it's best to consult the manufacturer's specifications, as generally these are used on compressors. It is always a good idea to check the capacitance rating with your meter to make sure the capacitor is at the rating needed for the job.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.